Tangents drawn from an external point. Example: prove that a parallelogram circumscribing a circle is a rhombus. Solution: here is a circle with a parallelogram circumscribing it. We must prove that this parallelogram is a rhombus. A rhombus has all four sides equal. Look at the picture. There is only one theorem that we need to use. The theorem states that the tangents drawn from any outer point of a circle are equal to each other. In the picture, SM is equal to SP. Similarly, MT is equal to TN and VO is equal to VP and OU is equal to UN. On adding these equations, we get SM plus MT plus VO plus OU is equal to SP plus VP plus TN plus UN. Similarly, SM plus MT is equal to ST and VO plus OU is equal to VU. Also, we can say that SP plus VP is equal to SV and TN plus UN is equal to TU. So, ST is equal to VU and SV is equal to TU. As STUV is a parallelogram and ST is equal to UV and SV is equal to TU, opposite sides 2ST is equal to 2TU or ST is equal to TU. Hence, we obtain a quadrilateral whose adjacent sides are equal. Therefore, STUV is a rhombus.